Welcome. This lesson is the first in a series about the X-ray beam. Radiographic images are created by exposing the patient to an X-ray beam. The X-ray beam is actually composed of millions of individual X-rays. So what is an X-ray? An X-ray is simply a tiny package of energy that we call a photon. That's why sometimes we refer to it as an X-ray photon. X-ray photons have a lot of energy, but they have no mass, they have no charge, and they travel at the speed of light. Their velocity never changes. X-rays are actually similar to light in some ways because both visible light and X-rays are part of the electromagnetic spectrum. The electromagnetic spectrum is the entire range of photon energies, and this includes some familiar terms. Radio waves, microwaves, visible light, X-rays, and gamma rays are all part of the electromagnetic spectrum. So these terms are all referring to photons. The only difference is the energy of these photons, which is controlled by the wavelength and the frequency. Wavelength and frequency are not complicated ideas. The wavelength is simply the measurement from one peak to the next peak. When we're talking about X-ray photons, the wavelength is commonly measured in nanometers. When the peaks are closer together, the wavelength decreases and the X-ray photon has more energy. But when the wavelength decreases, something else also happens. The frequency increases. This is the number of wave cycles per second measured in hertz. In this particular wave, the frequency is about 2.5 cycles per second. Both the wavelength and the frequency affect the energy of the photon. You can think of it like this. Both of these photons are traveling at the exact same speed. And for all photons, this is the speed of light. The only difference is the wavelength and the frequency. The upper photon has a very long wavelength, therefore it has a low frequency and very low energy. The lower photon has a very short wavelength. This results in a higher frequency and therefore high energy. So here's the general relationships that we need to understand. If the wavelength decreases, in other words, if the peaks of the wave get closer together, the frequency increases. That means there's more wave cycles per second, and the energy of the photon increases. Notice how there's no change in velocity, simply changes in the wavelength and frequency, and that's what influences the energy. Of course, the opposite is also true. If we were to increase the wavelength of the photon, the peaks would be farther apart, the frequency would decrease, and therefore the energy of the X-ray photon would decrease. So here's the thing about an X-ray beam. It's not made of just one energy. The X-ray beam is what we call polyenergetic, and that just means there's lots of energies. There's millions of photons in the X-ray beam, and all of these photons have a wide range of energies, some high and some low. Here's a graph of a typical X-ray beam energy spectrum. The x-axis represents the different photon energies in the beam, from very low up to very high. The y-axis represents the number of photons at each of those energy levels. So what's this graph telling us? The tallest part of the curve represents the average energy of the beam. The point of the curve that's farthest to the right represents the highest energy photons. There aren't very many really high energy photons, which is why the curve is so short there. So where did all of these photons come from? The large bell shape comes from a type of X-ray production that we call Bremsstrahlung radiation. The single peak to the right comes from characteristic X-ray photons. These X-ray production processes are discussed in greater detail in other lessons. When we're describing the number and energy of the X-ray beam, it's actually good to use some specific terms. The term quantity in the context of X-ray physics refers to the total number of X-rays in the beam. We sometimes call this the beam intensity. Quality is a term that refers to the average energy of the X-ray beam. Sometimes we just call this energy. The terms quantity and quality are also discussed in greater detail in other lessons. Finally, one more thing we should know about X-rays is that when they're created in the X-ray tube, they are created isotropically. Isotropic means that X-rays diverge equally in all directions. In fact, this is exactly why the X-ray tube assembly requires a protective lead housing. The lead housing absorbs all of the extra X-ray photons that we don't actually need. X-rays travel in straight lines, so they will keep on going until we put something in the way to stop them. If they don't interact with something, they'll just keep on going. So we use the protective housing to protect the patient and other people in the room from unnecessary radiation. In summary, here's some of the terms that we discussed. A photon refers to a single package of energy. An X-ray beam is made of X-ray photons. We also talked about the electromagnetic spectrum. This refers to the full range of photon energies. The electromagnetic spectrum includes X-rays, but also lower energy photons like visible light and higher energy photons like gamma rays. Wavelength is a term that refers to the distance from one peak to the next in a photon wave. As wavelength decreases, the photon energy increases. Related to this is the frequency. Frequency is the number of wave cycles per second. As frequency increases, the photon energy increases. Another term is quantity. Remember that quantity refers to the number of X-ray photons, and a similar term is quality, except this term refers to the energy of photons. Finally, we talked about the term isotropic. Isotropic refers to a condition of diverging equally in all directions. Here's a practice problem to make sure that you understand these concepts. An X-ray photon with high energy has which of these characteristics? Take a moment to think about this question and decide what you think the answer is. The correct answer is B, high frequency. When frequency increases, this means there are more waves per second and shorter wavelength, which corresponds to a higher energy photon. A is not correct because a long wavelength results in low energy. C is not correct because intensity refers to the number of photons, not the energy. And finally, D is not correct because the velocity of a photon is always the same. It's always the speed of light.